Hi everybody, so this is the video for section J, for the first part of section J, which is standard deviation. So standard deviation is another statistical measure, and it allows you to have a number that represents sort of like the variability of the sample. So are the values within the sample all over the place, or are they pretty consistent? So it's kind of like a measure of consistency. And you've seen two measures already that also deal with consistency. One is the range and one is the interquartile range. But those are not as good in some respects as standard deviation because they only look at two values. They look at sort of a top value and a lower value, whether it's of the entire sample or whether it's of the middle 50%. But standard deviation allows you to look at the variability of every single value within the set. So it's got a pretty scary, maybe looking formula that goes along with it, but when you break it all down, it's not so bad. So in the formula, S stands for standard deviation. This symbol we've seen before, and it represents the sum of. So we're going to take the sum of, and then in this set of brackets, we have every value within the data set minus the mean, X bar. And then we're going to take all of those, so each value within the data set, we're going to subtract the mean from it, and then we're going to square it. And every one of those, then we're going to add them all together. Then we're going to divide it by n, which is the sample size, so how many data sets or data points do you have within the set, and then we're going to square root the whole thing. So at first glance, you might be thinking, holy cow, that formula looks pretty intense. But we're going to break down a way of sort of setting it up and using it that's not so bad. Okay, so let's go through an example. So here's the scenario. We've got oranges that we're buying from two different wholesalers. And we kind of want to look at which wholesaler should we go with, sort of which one is going to be better. And so we take a sample of oranges from each of the wholesalers and we examine them for blemishes. So how many marks are on them, how many bruised spots, how many whatever. So here are the results. So wholesaler A, the one orange had 4 blemishes, one had 16, 14, 8, and 8. And then wholesaler B, one orange had 9, 12, 11, 10, and 13. So that's the scenario. So you might be looking at that and making some assumptions about which wholesaler you think is better just by looking at the numbers themselves. Let's look at standard deviation as giving us some ammunition to kind of support maybe our belief. So we're going to start with wholesaler A. So this is the formula for standard deviation. This is what we want to be able to use. So in order to use this, we need to figure out the mean. So I've got the mean sort of set up here. The mean X bar is equal to the sum of all the data points divided by the number of data points we have. So over here, I've got a little chart that's going to be really helpful for us to kind of piece this whole thing together. So in order to figure out the mean, the first thing we need to know is the number of data points, or the sum of the data points we have. So here's our list of data points, and if we add that all up, we get 50. So into the formula, we've got X bar. Now I know that the sum of the data is 50, and I know that we have 5 data points. So X bar, my mean, is going to be 10. Okay, so on average, the oranges that we're getting from wholesaler A have 10 blemishes. Okay, good. So now, the next thing we need to figure out is we need to figure out this part of the formula. Take each of the data points and subtract the mean from them. So again, the next column of my chart is going to be just that, taking each of the data points, subtracting 10 from them. So if I do that, I get -6, I get 6, 4, -2, -2. Okay, great. So then I'm going to take each of those differences and I'm going to square them, which is the next column of my chart. So if I square them, that's what gets rid of all of your negatives for you. So you don't care if the difference is positive or negative, you just care about how far away it is from the mean. And that's why we're going to end up squaring here and then in the end square rooting. So that's sort of a little bit of an inside track on what we're doing here. So the next part that we need is we need the sum of all of these differences that we just squared. So I just squared all the differences, so now I'm going to take the sum of all of these, and if I add that all up, I get 96. Okay, so once you kind of do this chart, all of a sudden using this formula, is not so bad, because we already have figured out this top number, which is just a single number. The sum of all those differences squared is 96. So my next line of work here is going to be 96 on top, and the number of values that I had in the data set was 5. So all of a sudden, we just reduced this kind of crazy looking formula down to just 2 numbers, take the square root of them. So if I do that division on my calculator and then square root, I'm going to get, and I should probably be using an approximate because I'm going to round this. So it's approximately 4.38. So the standard deviation of wholesaler A is 4.38. Is that good? Is that bad? It's a low number. The lower the standard deviation, the more consistent the data is. It depends on the scenario as to whether or not that's what you want. But this is looking like, on average, each of the oranges that we get varies from the mean by about 4, which isn't so bad, maybe. So let's have a look at wholesaler B. So I've got the same scenario set up here for wholesaler B. I started with the original equation. I've got an equation in the middle to find mean, and then I've got my chart. So if we start by adding up all of these numbers, we're going to get 55. And so x bar, the sum of my values is 55. The number of values is 5. So my mean here is 11. Okay, so all of a sudden we can now make one comparison between A and B. So wholesaler A had on average 10 blemishes per orange. Wholesaler B has an average of 11. So all of a sudden we've got one way of comparing. Wholesaler B on average has more blemishes per orange than wholesaler A. Okay, so that in my mind is like a point to wholesaler A. Let's work out standard deviation. Okay, so now we're going to take each of our values and subtract 11 from them, because that was our mean. So we've got -2, 1, 0, -1, 2. Then we're going to square, oh, I forgot my squared on there. We're going to square each of those values. So now we've got 4, 1, 0, 1, 4. And then in the end, I'm going to need to sum all of those differences squared. So if I add up all of that, I get 10. And then over to my formula, I've got the square root of 10 over, and then the number of values I had was 5. So again, not equals, because I'm going to round this approximately. So I would do that division 2. So I'm looking at the square root of 2. So it's approximately 1.41. So now that you have the standard deviation for both wholesalers, now you can make some conclusions about which wholesaler you might want to go with. So wholesaler A, on average, has less blemishes. However, there is much more variability with wholesaler A. Wholesaler B is more consistent because it has a smaller standard deviation. So you can sort of look at it as, you know, kind of what you're going to get with wholesaler B. On average, you're going to get more blemishes, but they're much more consistent. Wholesaler A, you're going to get fewer blemishes on average, but there's much more variability within them. So, I mean, the thing with all of this statistic information is that there's no necessarily right or wrong answer per se. There's only sort of numbers that will support one conclusion over another. So if you were asked to pick your wholesaler, it depends on what you want. Do you want more consistent product, or do you want to sort of roll the dice and go with, on average, fewer blemishes? And that's where sort of your explanation of your answer is going to be much more important. So that's how to find basic standard deviation. So you start with the formula. A chart is really, really, really helpful if you're going to be doing this by hand. Remember that in the calculator section, we talked about how to find standard deviation. So you can always use your calculator to check that answer. But if you are asked to do it by hand, you need to actually do it by hand. If it says a calculator is fine for everything, then a calculator is fine for everything. So that sums up the first part of standard deviation. In the next video, we'll go into sort of more complicated examples.